Okay, good. Yeah, so this is about a recent addition to Scikit-HEP, PyHepMC. It's an interface to the HepMC3 library, and the latest version is 2.71, which I just released today. So yeah, it's on PyPI, and you can find documentation and source under the usual links. So the HepMC3 C++ library is you can find under this link or this nice paper where it's written up why you want to have this. So basically, it's a library around an ASCII format that people use to store simulated event records. So when you run Pythia or so, you may want to store the output and put it into some other software. And then a standard way of doing this is this HepMC format. And in the library layer, this is implemented in an object-oriented way. So you have an event object, and you have particle objects and vertex objects, and so on. And these are all classes. And you can put some metadata on the run level, on the event level, the particle or the vertex level. So yeah, this is the typical workflow. So the point of this format is to decouple the generator from the back end, or maybe for us it's more the front end. So the detector simulation, or if you want to run Rivet or so, that would be the lingua franca to connect the two. So PyHepMC is a handcrafted Python interface to the C++ library. It's built on Python 11, and it was previously known as Pyhepmc-NG, but then I made an agreement with Andy Buckley, who was the maintainer of this PyHepMC package that existed since a long time, on PyPI, and so now I can use this name. So PyHepMC was originally proposed for inclusion in this distribution of HepMC3, but the authors unfortunately prefer to automatically generate the Python interface with CPP binder, which, by the way, works very well, but it's then automatically generated, just a direct mapping of the C++ interface. So you don't get the nice Pythonizations that this one has. And another benefit of PyHepMC is also that you can just pip install it. And we provide, as usual in Scikit-HEP, we provide precompiled wheels for common platforms. So you can just install it and it runs immediately. And it includes the HepMC3 library internally, so you can just start working. So I said that the API in Python is Pythonic. So for example, the C++ one, of course, doesn't have properties. So it uses setters and getters a lot. And these are mapped to properties in Python. The API also doesn't give you the native C++ types, but it gives you native Python types wherever possible, and does automatic conversions between the two. And then I also added a very simple I/O with just an open method. It is kind of inspired by how Uproot provides an open method to read and write files. And finally, there's flexible import system for the legacy HEP event record. That is what people used in the Fortran days. And for example, Pythia 6 writes its event in this way. And also working with the authors of the impy generator frontend, which provides the data in this format. Some of the nice things you get automatically is the visualization of the event with Gravis, and so the particle library, when you have it installed, also gives you then nice tooltips here in this library, so this visualization. So you can just point to one of those particles here, and then you get some extra info like the mass or whatever. And yeah, I told you about simple I/O. So you just import a library, and then you can use this open method. Of course, this is a context manager. So you can just open a file like this, and then you can iterate over the events in that file. And when you have particle also installed, you get great synergies because you can look up the name based on particle ID, for example. So here I just show you what you can do quickly to inspect some event. So this is sorting the particles that are final state in the event record by energy, and it outputs the energy, the particle ID, and the name. The name is provided by particle. yeah, this is how it looks like. So one liner, it's nice. Yeah, I told you about some attributes. So this is kind of cool. So you can, in principle, add some metadata, and this, yeah, can be arbitrary metadata almost to the event or the run or so on. So, for example, one of the built-in attributes, so to say, is the so-called RunInfo. So here you can put in information on the generator. Or you can use this feature, for example, to mark certain vertices. So here is an example where I mark all the vertices that have photons as children, I mark as sparkly. And that is using the general attribute system. So I can give these attributes some name, and then I can provide here almost most of the basic Python types I can add here. So for example, was a Boolean. And then this I can store in the ASCII format and read out later again and then work with that. So something I just added was transparent decompression. So this is also something that the C++ library implements, but yeah, then you need some extra libraries, and I implemented it using the Python standard lib. So this supports gzip, bzip, and the lmza format. So this is very simple. You just have to provide the right extension here, and then the open method will automatically read this file, even if it's compressed. Or you can also write it in a compressed format like this. So summary, PyHepMC is a Pythonic interface to this HepMC3 library. Supports all the formats that this library supports. And also new is that there's full documentation now with doc strings. So you can use help on all the classes and you get nice docs. And these are actually pulled from the C++ library. And you have these event visualizations in Jupyter, which are useful. And yeah, almost all of the C++ API is covered. Only some minor parts are missing. And if you are participating in a hacker shop, you can actually make this closer to 100% with me. And yeah, it's also heavily unit tested, of course, like all my libraries. Okay, that's all. Thanks.
Okay, excellent. Thanks very much for doing a great job of sticking to time. And yeah, also it's quite nice to see PyHepMC be in Scikit-HEP now. So really nice talk. Let's see, we have 2 minutes or so, so maybe we can see if there's any questions. All right, so I don't see any questions on Slido, so I guess I'll take some chair privileges and just say I think it's also nice, given that since you're using PyBind 11, like you're actually still kind of like distributing the library. So this means that you can, if I'm correct, this means you can pip install PyHepMC and also still get the underlying C++, so that if you wanted to still be able to hook in with like Pythia or something else, you'd be able to still direct Pythia to use the HepMC3 library that's shipped as well, correct?
That's an interesting point. So that's not how it is done right now, but I mean, in principle, I could do that. So I'm currently, for simplicity, I just compile object files and I don't make a separate library out of
okay.
the
Yeah.
Okay. But I could do that. Maybe it's
that because you match the compiler and that sort of things.
Sorry, Henry, can you say that again? I didn't quite hear you.
I said you could potentially run into issues there, because like if you get a wheel, that you might, that will be compiled with some particular compiler, and you might, if you have a much newer compiler, there could be some issues.
Yes.
Trying to use that as a binary distribution method, which wasn't really intended to be.
Yeah.
Depends slightly on what you're doing.
Yeah. Okay, so we have one more question, and then we'll go to Henry's talk. So we have a question on Slido. For the missing parts of the API, is it possible to drop down into the auto-generated binding seamlessly? I think I know the answers to that, but I'll still let Hans go for it.
I'm not sure I understand the question.
I think that they were. I think this question asker might not be familiar with PyBind 11, but the PyBind 11 bindings are a replacement for these auto-generated bindings. I believe the answer to this question is no, because it's a bespoke craft. Hans has made a bespoke kind of handcrafted API.
Yeah, that's correct. Yeah.
Okay, great. Yeah. So